The Drift by Sanford Lab, where our researchers answer your giant science questions in bite-sized videos. Submit your questions via direct message on Facebook, Instagram, and Twitter.
Hi, I'm Mark Hanhardt, and this is The Daily Drift. Today's question is, how do we study stars from underground? Now that's a question that comes up a lot, and rightfully so, because it doesn't make sense, the idea of going underground to study stars, right? Where there's a mile of rock over your head that clearly obstructs the view of the stars. But there's an experiment underground called CASPAR, the Compact Accelerator System for Performing Astrophysical Research, that's endeavoring to do just that. The goal of CASPAR is to use a particle accelerator to understand how the stars burn, how they generate the energy that they do, and how they build up all of the elements heavier than hydrogen and helium that then go on to make the universe a more interesting place, a place where rocky planets are possible and where life can form. So the way CASPAR works is it uses a particle accelerator to accelerate particles such as protons or alpha particles at some sort of target. The idea is that when these protons or alpha particles impact the target, a handful of them will undergo nuclear fusion, which is the same process that takes place inside the core of a star, such as the heart of our own sun. The idea is that by watching this reaction unfold up close, very carefully, watching the energy that comes out of it and the particles that come out of it, we can understand better how these processes actually take place inside the core of a star. And that's something we can't see through a telescope. So the only way we really have of understanding these processes is by going a mile underground, where we can block out all the cosmic rays and radiation that take place on the surface and studying these reactions up close. So in a nutshell, the way we study stars from underground is we recreate the heart of a star inside of a particle accelerator, and then we watch those nuclear reactions unfold very closely. So thank you for joining us on The Daily Drift. Please continue sending us your questions on Facebook, Instagram, and Twitter. Thank you.